Okay, so let's take a look at the solutions to this numeracy check then, where we were working on exchange rates, money problems, percentage change, averages, bearings and constructions. And question 1 was on exchange rates. So Theo went on holiday to Brunei. He changed £950 into Brunei dollars when the exchange rate was £1 equals 2.12 Brunei dollars. So for every pound he has, he can buy that many that many Brunei dollars. So £950 he will get $2,014 Brunei dollars. Whilst on holiday, he went on a trip which cost £180. What was the cost of the trip in pounds? So now we're going to turn Brunei dollars into pounds. So if multiplying takes us from pounds to Brunei dollars, dividing will take us the other way. So 180 divided by 2.12. £84 and 90. The next, if we round it to the nearest penny, the next digit's a 5, so that would round up to 91. But in that question, you'd get full marks even if you had it as £84.90. And most of you got full marks on that question. Question 2 is a slightly more complicated exchange rate question. Amrit is planning to go to Switzerland. The table below shows the rates of exchanging British pounds and Swiss francs at a money exchange shop. So £1 buys £1 1.24 Swiss francs and 1.28 buys £1. The exchange rate has the exchange shop has all the possible British notes and coins, but only buys and sells notes for the Swiss franc, but has a full selection of notes. Amrit has £480 to buy Swiss francs. Calculate the maximum number of Swiss francs that Amrit can buy and how much the nearest penny this will cost him. Okay, so he has got £480 and for £1 he can buy 1.24. So the total possible value he can buy is 595.2 Swiss francs. But you haven't got any coins available to you, so you need to work out how much of that you can make up using notes only. You've got 500 you can make up out of those, then you've got a 50, and then you've got two 20s and no 5s. So the most you can buy is 590. So although you've got enough money available to buy that much, you can't buy 600 because you haven't got enough money in English currency. So that's the most that you can buy, and that's going to cost you, or Amrit, 590. Now, just like in question 1, we're wanting to go backwards through the exchange rate. So rather than multiplying by 1.24, we're going to divide by 1.24. So we do 590 divided by 1.24 is £475 and 81 pence. Question 3. So this is a lot of information in this question. So Grace sees a newspaper advert for Blake's Mopeds. So Blake's Mopeds, best deal valid if you show this advertisement. So if you take this along, you'll get this deal. You'll get a moped for £400. You get an £80 helmet, but with a 15% discount. And then on top of that, you need to get insured, which costs £151.20, and taxed at £37. Grace is planning to save for this offer. She also wants to save enough money for the first month's fuel, and that's important. Quite a few of you got in a bit of a knot with the cost of fuel. The moped travels 20 miles on a litre of fuel. A litre of fuel costs £1.26, so we got 20 miles per litre. A litre costs £1.26, and Grace estimates she will travel approximately 350 miles each month. So in that first month, she's going to travel 350 miles. Starting this month, Grace will be able to save £60 a month. After how many complete months will Grace have saved enough money for this offer, including the first month's fuel? Right, so before we can work out the total cost, we need to work out how much the fuel is going to be and how much the helmet is going to cost, because everything else is fixed. So let's work with the helmet first of all. So cost of helmet will be, so you can either find 15% and take it off, or you know that if 15% is coming off, then there's going to be 85, it's going to cost 85% of what you've got there. So it's going to be 85% of £80. So I'm going to use the percentage button. If you prefer to write it as 85 over 100 or a 0.85, that's entirely up to you, so long as you get it right. So 85% of 80 is £68. So it's a 68. The cost of the helmet is going to be £68. If you wanted to do it by finding 15% and taking it off, then that's fine as well. You take £12 off and you get 68. So the cost of the helmet is £68. Right, let's concentrate on the fuel now. She's going to travel 350 miles each month, and you can go 20 miles on a litre. So we can work out how many litres she'll need in a month. Number of litres of fuel. So she's going to travel 350 miles, and in 20 miles she goes 20 miles on a litre. So 350 divided by 20, 17.5 litres. Some of you rounded that to 18 and then you lost some marks for that. Leave it at 17.5. There's no reason to round that up. So she needs 17.5 litres, and each litre is going to cost £1.26. So the cost of 1 month of fuel will be 17.5 times £1.26. So £22.05. So the total cost that she needs to save will be the 400 plus the helmet, which is 68, plus the fuel, which is £22.05, plus the insurance, which is £151.20, plus the tax, which is 37. So 400 plus 68 plus 22.5 plus 1,520 plus 37 equals 78, 678 pounds 25. And she's going to save £60 a month. £678 25 divided by the amount each month, which is 60, which is 11.3 months. But the question's asking how many complete months. So if she's only saved for 11 months, she'll still be short because she needs to go that bit further. So the number of complete months that she needs to save is 12. And then she'll have a little bit left in her bank account afterwards. Okay, so with the question like that, it's really, really important you read the whole thing. What I suggest you do is you read the whole thing through once and then go back, and when you're reading it a second time, that's when you want to start highlighting the key little parts to that and then breaking it down. Okay, question 4, percentage change for the first one. So the percentage increase is, first of all, how much has it gone up? So I haven't read the question, sorry. A town's population increased from that amount to, in the year 2000, to 21,831 at the end of 2015. So the actual increase will be 21,831 21,831 less 14,268. 21,831 less 14,268. So there's been a 7,563 person increase. Now we want that as a percentage. So whenever you've got a percentage change, whether it's an increase or a decrease, it's the amount of increase or decrease divided by what it started. What was its starting value? Well, the starting, it moved from 14,268. So if the question was asking you what fraction, that would be the answer. And then to turn the fraction into a percentage, you multiply by 100. So on your calculator, you've got a fraction button, and your calculator looks slightly different to this one, but it's not that far off. 2,563 at the top of the fraction, 14,268 on the bottom, times 100, so it's increased by 53%. Rashid was given a 3% salary increase. His new salary is 25,544. How much was his his previous salary? So if you look back at the start, this question 4 is a reverse percentages question. Now, if this was a full GCSE paper, we'd be well into the second half of the paper here. And if you remember what I've been saying to you in class, if it seems too easy, if you just think, well, I've got to take 3% of that, find 3% and take it off. That's not a grade B question. This is a reverse percent. So what this is saying is, he's had his original salary was given a pay rise of 3%. So his new following 103% pay rise, he has now got a salary of 25,544. And what we want to know is what it was before the pay rise. So he was working, he was being paid a salary. He was given a 3% increase, which means that's the multiplier is 100 plus 3% is 103%. So if I knew what that was and I multiplied it by 103, I would get this. So I've got to go the opposite direction, which means I've got to do the opposite of timesing by 103%, which is dividing. Okay, so I have to do 25544 divided by 103% or 103 over 100 or 1.03, depending on how comfortable you are with that. So 25544 divided by 103%, giving you the answer of 24,800. So you would never get a question in the second half of a GCSE paper where you're just going to find 3% of that and take it off. It's a reverse percent question, you've got to be sniffing it out. Question 5. The price of fuel has increased by 20% each year. The cost of fuel was £1.49 a litre on the 1st of January 2015. If the price of fuel continues increasing at the same rate, what would you expect the cost of the litre of fuel to be on the 1st of January 2020? So this is a compound percentage question, it says it on the front, where you're starting with an original value and then you are repeatedly increasing or decreasing it by the same rate. So this one is being increased by 20%. So my multiplier, it's an increase. So from that original amount, I'm going to add 20%. So my multiplier is 120%. My original is £1.49. So I'm going to multiply that by 120%, and then that will be to the power of the number of jumps. So I'm going from 1st of January 01 2015 to 01 2016 to 01 2017, 01 2018, 01 2019, 01 2020. That's 1 year, 2 years, 3 years, 4 years, 5 years. So all I need to write down for this is £1.49 times 120% to the power of 5. Everything else I've done there is just to help explain what I'm doing. So £1.49 times 120%, okay, or in there you could put just 1.20 or 1.2 or 120 over 100, however you want to do it, so long as it's the correct version of 120%, to the power of 5. So I've typed it into the calculator exactly as I've written it, and that gives me the answer of £3.71. So that one line there earns you 4 marks. After an increase of 24%, the cost of 1 tonne of coal is £451.36. Calculate the cost of 1 tonne of coal before the increase. It's a reverse percentage. I want to find the original amount. So original times my multiplier, that's an increase, so it's 100 plus 24%, would give me 45136. So to get the original, I've got to do 45136 divided by 124%. I need to travel backwards to work out what that original was. So my calculator, 45136 divided by 124%, £364. So again, second half of the paper, it's not going to be as easy as working out what 24% of that is and taking it off or adding it on. Question 6 is another compound percentage question. So it's going to be like that there. Wood pulp is used to make paper. In 2012, Brazil produced 14 million tonnes of wood pulp. So there's my starting point. In each of the next 3 years, Brazil's production of wood pulp increased by 1.7%. So it's an increase, so it's going to be 101.7% for 3 years. After 2015, it is expected that the production of wood pulp will increase by 2%, so 102% of each previous year's production. What quantity of wood pulp would you expect Brazil to produce in 2017? Okay, so the 5 marks for one line of maths here. We're going to start with 14 million, but we put the million in afterwards. So it's going to be 101.7% is my first multiplier, and that's for 3 years. And then after 2015, it's going to increase by 102% for the remaining, so we're going to 2015, 2016, 2017 is another 2 years. And we can put that into the calculator in a single line. Just remember we're talking about 14 million when we get our answer. (101.7% to the power of 3 times 102% to the power of 2. So it's going to be 15.3 million tons. Okay, I'll put the word million there because I started with 14 million, so we're going up to 14.3 million tons. So once you get into the groove with this, once you get used to adding 100, adding or subtracting your percentage to 100, and then to the power of the time interval, it's really easy marks. Okay, so we're leaving percentages behind, and we're coming now into the average work. So 5 pupils attended a dance every Thursday. For these 5 pupils, the median of their ages is 7, the mode is 18, the range is 8, and one pupil is 2 years older than the youngest pupil. So we've got 5 pupils. So let's put our markers in where we're going to put these values. So that's going to be an ordered list of their ages. So the median is 17, which means the middle age is 17. So I know that I can put 17 in there. Their mode is 18. So that means there's more 18-year-olds than any other, which means both of those must be 18. The range of their ages is 8. So the gap between the oldest person and the youngest person is 8, which means the youngest person must be 10. And one pupil is 2 years older than the youngest, so that person must be 12. Colleen now joins the class. She is 2 years younger than the mean age of the other 5. So if we work out what the mean age of these 5 are, so 10 plus 12 plus 17 plus 18 plus 18, mean will be the total 75 divided by count, where there are 5 of them. So that equals 15 years. She's 2 years younger than the mean age of the other 5 pupils, so she must be 13. So Colleen is 15 minus 2, 13 years old. Most of you got full marks on that. This was the one that lots of you got confused with. The table below shows the number of different priced season tickets that a football club sold last season. So we get the cost of the ticket. So there's a £250 season ticket, a 300, a 350 and a 500. They sold 6,000 tickets costing 250, 8,000 tickets costing £300 and so on. Calculate the mean cost of the season tickets sold last season. So they sold 6,000 tickets, each costing £250. So the total number of tickets sold at £250, the total value of those is going to be 6,000 times 250. So that's 15 followed by 1, 2, 3, 4, 5 noughts. And I want to work at the total value of the tickets sold altogether. So now I need to do 3,000 times 8,000. 3 8s are 24, followed by 5 zeros. Then I've got 350 times 8,000 is 28, followed by 5 zeros. And 500 times 3,000 is going to be 15, followed by 5 zeros. So the total will be the sum of those. So that's going to be that plus 28, 1, 2, 3, 4, 5, plus 24, 5, plus 15, 1, 2, 3, 4, 5. So 82, all the way 1, 2, 3, 4, 5. And the count is how many tickets were sold, which is the total of this column. So we've got 6,000 tickets sold of the 250 cost, 8,000, 8,000, 3,000. So they sold 25,000 season tickets altogether. So the mean will be 82,000. So what's that? 8,200,000 divided by 25,000. So £328, which looks about right. 328, that's where most of the tickets were sold, so I'm quite happy with that answer. It was alarming how many of you were dividing by 1, 2, 3, 4, or you were adding that column up and that column and dividing them. Considering you only looked at that a few lessons back, that was a bit worrying. But then the harder version, you could all remember what to do. So question 9 was much better answered than question 8, even though it's a more difficult question. So in Bilkbach, the rainfall for each of 10 days was measured. The results are summarized in the table below. So daily rainfall are between 4.5 and 5.5, 4 days. So there were 4 days where the rainfall was between 4.5 millimeters and 5.5 millimeters, and so on. Calculate an estimate for the mean daily rainfall. So it's an estimate because although I know there were 4 days with rainfall between those two values, we don't know exactly what it is. So we choose a midpoint or mid value and use that. So halfway between 4.5 and 5.5 is 5, 6, 7, 8, and 9. So there were 4 days where we're saying the rainfall came to 5 millimeters. So that's 20 millimeters in total. 12 millimeters, 0 millimeters, 16 millimeters, 18 millimeters. So the total rainfall altogether is going to be the sum of those. So 20 plus 12 plus 16 plus 18 is 66. Mean total divided by count. So 66 is in total. It's telling me there are 10 days. If it didn't tell me that, I would add those up and get 10, giving me 6.6 millimeters. State the modal class. So I'm looking for the group which occurs most frequently, which is this one because it occurs 4 days. So 4.5 is less than R is less than 5.5. Write down the class in which the median lies. So it's 10 days. I'm looking for the group which has the fifth in. These are in order, so by the time I've come to the bottom of the lowest class, I've covered 4 days, and then the fifth day is in the second group, because by the time I get to the end of that, I'm at 6. So the median is 5.5, is less than or equal to R, which is less than 6.5. On the graph paper below, draw the frequency polygon to show the rainfall data. Now I give you a hand here because I haven't covered frequency polygon with you. We did a grouped frequency diagram in a question last week. Now the group frequency diagram would be where you've got connected bars. So 4.5 to 5.5 would have been 4. Then you've got 5.5 to 6.5 would have been 2. That's 4. That's 2. So that would have been a grouped frequency diagram, etc. So then we'd have had nothing between 5.5, 6.5 and 7.5. 7.5 to 8.5 would be 2. And the last one would be 2. So that would have been a grouped frequency diagram. A frequency polygon represents the same data, but rather than drawing columns, it just plots the midpoint at the top of where the bar would be, the frequency. So the midpoint, 4.5 to 5.5 is at 5, and that's 4. 5.5 to 6.5 is at 2. So then 6.5 to 7.5, so 7 would be 0, and then 8 would be 2, and 9 would be 2. So to complete that frequency polygon, would look like that. So both of those graphs show the same data. You need to be able to recognize which one you have to draw. So if it's a frequency polygon, you've got points and corners like you would on a polygon. Group frequency diagram is like a bar graph. Question 10. So we're coming into bearings now. P and Q are two ports shown on a map with a scale of 1 centimetre is 8 kilometres. Find the straight line distance in kilometres from P to Q. So P to Q is that distance there, and you need to measure it as accurately as you can, and I'm measuring that to be 7.5 or 7.4. So 7.5 centimetres, every centimetre is 8, so this is a bit like an exchange rate. I'm exchanging from centimetres to kilometres. .60 kilometres. So there's 3 marks for that. 1 mark would be for accurately measuring that length, and then there'd be a method mark for timesing that by 8, and then your answer mark. So if you incorrectly measure that, you can still get the 2 marks for multiplying by 8. There'd be a tolerance of plus or minus 2 on that. So if you measured 7.3 up to 7.7, you can still get the 3 marks. A ship is on a bearing of 147 from P, so I'm at P, and on a bearing of 0.21 from Q. Plot the position of the ship and mark it X. So bearings are measured clockwise from north. That's the only learning you have to do. So from P means I put the center of the measurer on P and I line the 0 up with north, and then I'm measuring 147. So I'm counting around from 0, 120, 130, 140, 145, so 147 is there. And I'm going to draw a line then, extending through that point that I just marked. I know the ship is on that line somewhere. To work out where, I now put my measurer on Q, 0 line up with north, and I'm measuring 21 degrees. So 0, 10, 20, 21 degrees is there. And where the 2 cross is where your ship is. So that's question 10. Question 11. So we start off with the construction. So it's saying here the diagram is not drawn to scale, so you can't measure anything. A construction company is working on plans to lay a new broadband cable. A section of the cable makes a turn at an angle of 30 degrees. Using a pair of compasses and a ruler, accurately draw a line on the diagram below to show where the cable is to be placed. Okay, so you've got to use a compass. Put compass point where you want the angle to be formed from, and then we're going to construct first of all a 60-degree angle. And the way we draw a 60-degree angle is first of all we draw part of a circle, an arc of a circle, then we move our compass point to where the arc crosses the extension of the line, and we make a cross like that, and that's going to be 60 degrees. Okay, so if we draw that in pencil, and you can check, because you've got your angle measurer, so you can check you've done it right. At the center of the angle measurer, at the center of where you want your angle to form, line the 0 up with the base and read up, and you can see there on the inside scale 60 degrees. But I don't want a 60-degree angle, I want a 30, so I'm going to cut that in half. I'm going to bisect it. Now if you remember the bisector construction, we make the arc that crosses the 2 lines on the angle we've got, and then we put the compass point where that arc crosses and move out into the center, and then we repeat that where the arc crosses the other side of the angle, oops, and we mark that in there, and that is going to cut my 60-degree in half. So that is the 30-degree angle here. Now what the examiner is looking for are these construction arcs. So we're looking to see that where that one crosses and those cross. And then finally another bearings question. So a further section of the cable is to be run from Pontllew to Maes Owen and then on to Wild Edge. Diagram is not drawn to scale, so although this is a bearings question, you can't measure anything. So if you remember when we were looking at bearings last week, what I said to you was north to south generates parallel lines. Wherever you draw north to south, it has to be parallel with every other north-south line that you would draw. So the above diagram shows the section of the cable from Pontllew to Wild Edge. Write down the bearing of Maes Owen from Wild Edge. So we're standing at Wild Edge and we're turning from north in a clockwise direction around until our line of sight is looking at Maes Owen. Now if that's 74 there, using parallel lines and alternate angles or Z angles, if that's 74, I know that that is 74. So if I want to work out that complete turn, moving from north to south is 180 degrees, and then I've got to turn another 74 degrees in order to get to look at Maes Owen. So I'm going to be doing 180 plus 74, which is a bearing of 254 degrees. Maes Owen from Pont-Lliw means I'm now standing at Pont-Lliw and turning from north until my line of sight is looking at Maes Owen. So that angle there is my bearing. Using the parallel line, I can see that if that is 52, that is 52. So I'm turning, I'm not going through 180, I'm stopping 52 degrees short of 180. So what I have to do is 180 less the 52, which is 128 degrees. So there we are. Those were the questions that we've been practicing over the last 4 weeks. Please make sure that any that you got wrong in the assessment you have a good look at and make sure you understand what I've been explaining there.